This is going to be a quick video to show the basic approach for building the womb chair. Here you see I have the completed chair portion with some fabric applied as a material. The proportions are not very good. The real womb chair should be flatter on the top and flatter on the bottom. The backrest area should be bigger in comparison, but the basic approach I think works okay. Also, this edge treatment needs a little bit of improvement. That doesn't matter for now. If we look at the chair from the side, we see that the backrest is perfectly flat. And if we zoom in to the top, we can see this edge here, which represents the seam, and material has been added a little bit behind the seam, and a lot of material has been added to in front of the seam. What we are going to do is build what I'm going to call the primary surface, which aligns with the seam and is used to be offset either backwards or forwards to form the back surfaces or the front surfaces, or what I've been calling the outer surface, and I'll call this the inner surface. I'm going to roll the feature tree all the way back to that primary surface. This is what I'm calling the primary surface. It consists of what I call the hood, the armrest, and the seat surface. There's also going to be a backrest surface, which we will see shortly. The armrest is planar, and the hood and the seat surface are boundaries. I'm going to turn on my sketches, and I'm going to back up a little bit and say a few things about the layouts. I always like to start with the side layout for a chair. It seems like that's where most is going on. And here we have the back surface, or back and bottom surface of the primary surface. These are the edges of the primary surface. This is the edge of the hood, the edge of the armrest, and the edge of the seat area. And I've also drawn another line inboard of that, which represents where the inner surface is going to be. And I probably should have drawn another line back here to represent where the outboard surface is going to be. In fact, let me just edit this for a minute, and I'm going to make these construction lines, and I'm going to offset these lines outward by about 0.4 inches to represent where the final outer surface or back bottom surface of the chair is going to be. Do not trust any of these dimensions. I made them all up, and that's why the chair was a little bit out of proportion, as you saw. A few key things is again the flat backrest. The seat surface slopes downward, as does the armrest surface. I'm going to color that layout red, and I'm going to move forward to the front layout. Here we see the seat, the armrest, and the hood from the front view. Let's make that purple. And before I move to the top view, there's another very important view I think should be put in before the top view, and that is a view that's going to be looking directly at the shape of the backrest. So what we have here is a plane passing through this line in the layout sketch, and then drawn on that plane is the actual shape of the backrest, which you see is sort of an oval or flattened oval sort of shape. I think it's important to have this before the top view, which will become obvious in just a moment. Before I move on, I'll point out that the side view has this continuing line from the armrest, because the armrest goes underneath the hood area, and I'm showing in the backrest area where that armrest is coming through. I didn't want to make this point coincident with the spline, because sometimes that can make the spline or mess up the spline, so I just showed this coming across the shape of the backrest, which I can utilize for my next view. So closing that, let's give this a color also. Make that like an orange. And let's take a look at this from the top view. Nice thing about having this drawn on its tilted plane is that we get an accurate view of what the backrest looks like from the top. We don't have to guess at all. So now when we draw the top layout, we can copy that oval into the top layout sketch. I can copy this line that goes across the oval, and that's going to give me the exact point where the triangular armrest touches the oval backrest. Then I have the shape of the hood, the front edge of the armrest, and the front edge of the seat area. This hood should probably be tilted more like this, but I don't think I'm using the top view for the hood anyway, so this almost doesn't matter. So closing that, and we'll make that green. But before I move on here, I want to just talk about how important it is to get everything lined up properly. This point lines up here. This point, which is part of the leading edge of the seat, is lining up with this point here, which is also the leading edge of the armrest. This point here is part of the armrest, which lines up with this point and is also the bottom of the hood. This point is also aligning with this point, so that's the inside edge of the armrest, and this point, the outside edge of the armrest, is lining up with this point. Zooming out a little, we can see the top of the hood aligning the top of the purple, and we can also see that this point is aligning to this point to give the leading edge location of the armrest. Now that I'm looking at this, since this point is the same as this point, and this point is a little bit lower and is the same as this point, I'm wondering if this line here shouldn't actually come down at a slight slope and this point be pulled down. Somehow my chair came out all right in spite of that, but you might want to be aware of that when you're making your own sketches. So I'll move on to making the primary surfaces. We'll start with the arm surface by extruding this edge copied from the front layout. And that's just extruded large enough to encompass this triangular zone, and then that triangular zone is trimmed from the top view. So that's our first surface. The hood is going to be made with a projected edge, a projected sketch using this view and this view projected together. So here is our projected curve. And our front edge of the seat is going to be projected from the front view and the top view. Don't use the side view to project this edge. So the hood surface is a simple boundary utilizing the projected sketch, a copied edge here, and a copied edge from that tilted plane layout of the backrest. So that's pretty simple, and this edge should go normal to profile so that when it mirrors, it will be a smooth transition across the mirror plane. Then the seat surface is also a simple boundary using this projected sketch. This edge is copied from the side layout, and this edge is copied again from the tilted backrest layout. So that's our primary surfaces. And as we know, the real chair has a big radius, this edge here, and a big radius here. And we want those radii to somehow end up in this area and resolving in such a way that we still have this nice clean edge for this oval backrest. The way we're going to do that is to trim out some areas where the surfaces meet and then build in some new transitional zones. So first, I'm going to sweep a circular cylinder along this edge using the swept surface command and using the circular profile option. Let me edit that. Using the circular profile option, I used in this case a diameter of 3 inches, which is the same as a radius of 1.5. And I had to extend that a little bit. Oops, let's go back a little bit. And I used that to trim out both of these surfaces. We hide that. Here's our gap. I used the same technique on this lower edge, extended the surface as necessary, and trimmed out that zone. So now we have a gap here and a gap here. I put a plane right at this endpoint, and then I put in a blending surface here and here, which are boundaries. The upper boundary has a 3D sketch that's been drawn from this point to this point and is equal curvature or tangent to this edge and this edge. And we also have another sketch drawn on this plane that I introduced, and that is going tangent to an intersection curve on the hood, and the control handle here is going horizontal. So that's my first blend surface, and the second blend surface is basically the same idea. A 3D sketch drawn from this point to this point, and another sketch drawn on plane 1 here going from this point to this point, and also using an intersection curve to be tangent to. So now here's where we managed to blend all this in to this area so that we maintain this oval shape. The way we do that is we make a copy of the oval from the backrest layout, and we simply make yet another boundary surface going from this edge to this S-shaped edge on these two blends, and then utilizing this edge and this edge, and trimming by direction 1 in order to make sure this surface doesn't go too far. So now what we've got is a blend that goes from this area into this area, which is maintaining this nice clean shape and softly blending this armrest into a clean edge here. Knitting that all together, that then becomes our completed primary surface. I can now introduce the backrest surface, which is a planar surface. This is just copied again from the backrest layout with an extra line introduced. Knit those together. I've got 1/2 of a chair. Now this is the surface that's really inside the chair. You would never actually see this except for this edge here represents where the seam is going to go. Now what I want to do is offset this surface backwards to form the outer surface. So I just offset this backwards by 0.4 inches. I don't know if that's the right number or not, but it seems pretty good. And then I want to just put a little fillet on this edge. If you look at the real chair, this edge is relatively sharp. This is a cord width fillet, 0.5 inches wide. So that's going to be our visible outer surface. And what we want to do is take this entire edge and pull it back a little bit and then build a new boundary that's going to go from that pulled back edge to this seam edge. To do that, I'm going to use the trick where we sweep a pipe along the edge of the surface. In this case, I use the edge of the primary surface to sweep. And then we use that pipe to trim away the excess surface of the back outer surface. So this has been pulled back a consistent amount all along the perimeter. That pipe is 2 inches in diameter or 1 inch in radius, so this edge has been pulled back by about an inch. Sorry, 1 inch. So I hide that. Now we've got our primary surface, which represents where the seam is going to be, and we have our outer surface, which represents a true surface, and we are going to build a transitional boundary here. I built this up in several steps. It's probably actually better to just build one long boundary with some cross-sectional shapes along the way to prevent the boundary from collapsing as it goes around these twists and turns. So I'll just show all of these all at the same time. So here's my boundary that's blending these together and giving my chair a little bit of a puffy shape. And then I knit that all together. So here we have, let's zoom in. So here we have the completed outer back surface of the chair. I'm going to hide that surface for now and get us back to our primary surface. And I want to offset this now in the opposite direction to form what I'm calling the inner surface, or that's the surface you would be sitting on and interacting with when you're sitting in the chair. Before I do that, I'm going to add a big fillet on this edge so that when I offset this, I'll have a little bit of a fillet remaining on the new surface that I'm offsetting. So here's my offset surface. Offset this about 1.8 inches forward. I really don't know what the true number should be. And you do see that what happens is we get a little bit of a jog here between the backrest and the armrest. And there's probably a way to make that look a little better so that this looks like a more consistent oval. And if I figured out how to do that, I will show you how to do it. But if you end up doing your chair like this and you get this little bit of a jog, I think that's going to be okay, and I think the real chair is a little bit like that. Furthermore, there's going to be a cushion sitting in here, and another cushion sitting down here, so I think it's going to obscure this little problem here. Now, one problem that has occurred when I offset this such a large distance is that the edge of the new surface is really odd looking, and I can't really sweep a pipe around this and utilize that for trimming the edge back because of the way this goes in and out. That trimmed back edge will look just as bad as this current edge does. So I'm going to have to use a few tricks to make this look a little better. So first I'm going to take and extend, first of all, this inner edge a little bit, because sometimes when you take a surface and offset it, the offset edge doesn't quite make it all the way to the original plane that the original edge was sitting on. So I'm just going to offset this edge, or extend this edge a little bit past the right plane, and then I'm just going to trim this back using the right plane again. So now I know that this edge is going right up to the right plane. So to clean up this edge, what I'm going to do is use the trick of sweeping a pipe again. I'm just going to sweep it down here, and another one that I'm going to sweep up here. These pipes have to be a much larger diameter because I want to cut this back further to give enough room for this cushion to curve down to the seam edge. You'll notice that I don't have a pipe in this area. These pipes are so big in diameter that they get crimped when they get through this tight radius here. I'm going to extend the pipe a little bit past the right plane at both ends. And instead of using them to trim, I'm going to make a 3D sketch, and I'm intersecting the pipes with my inner surface here So this is one of the intersection lines. Here's the other. And then I've gone ahead and drawn a 3D sketch from this point to this point, making it tangent or equal curvature at both ends. If I look at this from the top view, let's hide these pipes. Here's what that sketch looks like from a top view. Then what I do is I copy that into a 2D sketch from the top view. Nice smooth 2D sketch, and I use that now to trim away this excess material from my inner surface. So here's a nicely trimmed back surface, and this area looks much cleaner than it did before. And now I can do the same trick where I build a boundary surface going from this inner edge up to the seam edge, going all the way around the perimeter. And this has some additional cross sections in the direction too, helping the shape of this as it goes through the twists and turns. Otherwise this collapses real badly in this area. And you'll notice that this still is not perfect looking. This is really badly flattening out here, so there probably needs to be a plane right about here that has a nice curved cross section that helps hold the shape of this edge. Then I can just knit that together. So I have an inner surface and an outer surface. We don't really need the primary surface anymore. So let me just hide that primary surface and turn back on my outer surface. So we have the inner surface and the outer surface meeting at the seam. Later on we'll solidify this and we'll have a way of making this look like a true seam, which will look even more convincing when we apply some materials to this. So that's it. I know this was a very quick tutorial and I'll go over it some more in class.